Welcome to the first module of the Prompt Engineering course. In this module, I'll introduce you to the basics of artificial intelligence. But before we get started, let's make sure we're all on the same page. In this lesson, we'll give you conceptual knowledge about AI. You don't need to understand the theory in order to use ChatGPT proficiently, but having this knowledge will give you an edge over other users, especially in cases where ChatGPT gets to its limits. By the end of this video, you'll understand how AI was born and its journey to becoming the transformative technology it is today. Let's begin. Artificial intelligence is a broad area of research mainly focusing on things like machine learning, neural networks, robotics, expert systems, fuzzy logic, and natural language processing, also called NLP, not to be confused with neuro-linguistic programming. Throughout the course, when I say NLP, I'll refer to natural language processing unless I state otherwise. Natural language processing is the science of building computers that can speak like a human. Within natural language processing, there are so-called large language models, LLMs for short, which are the basis of apps like ChatGPT, Claude, or Bing AI. Now, I'd like to explain to you how NLP, natural language processing, works. In order to make machines understand humans, we must break down language into smaller parts, like words, phrases, and sentences, and teach machines to understand them. With this understanding, machines can perform tasks like analyzing how people feel about a topic, translating languages, and even generating new text. Early on in AI development, researchers tried using frequency-based approaches, where machines counted the words and phrases in a text to try and understand what the text meant. A practical example for this are search engines that use this method to understand how many times a specific keyword was found on a website. Another example for a frequency-based approach is the sentiment analysis of texts, where different words were classified as having positive or negative sentiment and knowing how often they appeared in a text. A machine could guess if the text itself was a positive or a negative one. However, this approach is ineffective for creating understanding the meaning of the text itself. We could compare that to trying to understand a song by counting how many times each word is sung. It just doesn't capture the melody, the feeling, or the meaning of the song. Imagine trying to understand Bohemian Rhapsody by Queen like this. It would be a nightmare. You would know that the word Galileo is a very frequent word, but it's obviously not a song about the Italian astronomer. As researchers continued to explore the potential of NLP, natural language processing, they developed word embeddings. This technique improved upon frequency-based approaches by relating words to each other within a multi-dimensional space. These were used in early chatbots and translator applications. However, word embeddings still lacked an understanding of word order, which is crucial for comprehending language. For example, you, a human, knows that dog bites man and man bites dog mean two completely different things. For these models, these two expressions meant the exact same thing. Then prediction-based models were developed. These models try to predict what the next word in a sentence might be, based on the words that came before it. It's like trying to guess the next word in a song by listening to the notes that came before it. Or like how the iPhone's autocomplete works, which uses predictive text models to predict which word you might want to type next. Finally, transformers are the new hotness in natural language processing. ChatGPT is based on OpenAI's GPT architecture, which stands for Generative Pre-trained Transformer. These models use so-called self-attention mechanisms to understand the context of each word and its relationship with other words in the whole sequence of text. This has led to machines that can generate coherent and realistic dialogue, just like you're talking to a real person. One of the most advanced uses of transformers are called large language models. To train these models, we give them large amounts of data, tweaking their parameters until they can generate realistic sentences. Yet it's equally important to teach them to function as courteous, beneficial conversational partners. This is where reinforcement learning human feedback, or RLHF for short, becomes crucial. Think of this process as a school grading system. Humans review the model's responses and provide education by marking what is good, akin to awarding an A grade, and what needs improvement, similar to giving a C or D grade. The model then tries to remember how it generated a good response, so it can do it again, and tries to forget the way it generated a bad response, so it doesn't do that again. You can also do this while using ChatGPT. OpenAI's CEO, Sam Altman, said that upvoting or downvoting a result from ChatGPT helps them a lot in training and refining the model and to make it safer to use. Now, training these models can be a challenging and expensive process shooting to millions of dollars. OpenAI has already done this for us with training the GPT models, but we need to keep in mind that large language models have limits. One of these limits is the token window. ChatGPT uses tokens and can only process a certain amount of these tokens at once, so we need to be careful with our prompts and context management. I'll explain this in a bit more detail in a later video. So to summarize, large language models are awesome tools for copywriters, freelancers, and everyone who generates loads of text in their work. To build your own, it requires a lot of resources and careful training. But fortunately, there are chatbots of trained large language models that are available for general use like ChatGPT, and there's also a new boom of open source language models. In the following lesson, we are going to look into the first and dominant chatbot that uses a large language model, ChatGPT. I can't wait to see you in the next video.